Okay, Charlie, we're going to fly off the cuff a little here tonight. Not sure exactly what you're looking at, but here we go. This one's going to teach a little bit about recognizing what to pick out from a question. And really, as I look more towards today's math problems, it's being able to read a question in its entirety, understand what the problem is, find the pieces of the puzzle within the question, and then use your knowledge to then apply those pieces to get the answer. So let's say that something were worded like, a square has a perimeter of 24 centimeters. What are the lengths of the sides? A square has a perimeter of 24 centimeters. What are the lengths of the sides? Here's what I do. I draw a picture every time. I draw the best square that I can, and I know that a square has something very peculiar about it. It has 4 equal sides. That's what makes it a square. And in the corners down here, these are 90-degree angles. And if you haven't learned about angles yet, it's almost time. And they'll have all of these ones, 90, 90, 90, and 90. And all the internal angles add up to what? 90 plus 90 plus 90 plus 90 is 360 degrees. Wait a minute. A circle. A circle is made up of angles that are 360 degrees. Crazy. It's not that crazy. And we're going to see a little bit later on, but right now, check it out. How do we solve that problem we were talking about? We know a lot about squares. We know probably some information that we don't need to know. And in this case, the internal angles add up to 360 degrees. That's just something nice to know. So for right now, let's concentrate on the part of the problem now we don't know. A square has a perimeter, yes, of 24 centimeters. What are the side lengths? Well, if you didn't know it was a square, you'd be reading because you'd have to know, well, there could be different side lengths? No, because we know that a square has 4 equal sides. So with 4 equal sides, we can call them anything we want. Let's call this side, I don't know, Charlie. Well, if this side is Charlie, and this one's the same, then this is also Charlie. And then this one would be Charlie, and then this one would be Charlie. You would have 4 sides, all called Charlie, and they would all be the same. So I would go, okay, well, I do know a perimeter means all around the outside. Total distance around the outside. So if I know that this square has a perimeter of 24 centimeters, I know that if I go all the way around the outside, that's going to be 24 centimeters. So how do I write that into an equation that makes sense? Well, how many sides do we have? We have 4. So we have 4 of them. And what are they called? They're 4 times Charlies. Yeah, we have 4 sides and they're all called Charlie. 4 times Charlie is equal to how many centimeters? 24. And I leave centimeters here because we want an answer that's in centimeters. We don't want it in feet or inches, so we keep the units. So 4 times Charlie is 24 centimeters. And we know from some algebra that if we're multiplying on one side of the equation, in order to get rid of this 4 that's in front of Charlie, then we have to divide this side of the equation by 4. So let's divide this side of the equation by 4. And what we do to one side, we have to do to the other side because it's an equation equal. So 4 times Charlie divided by 4, well, the 4's reduce. And 24 divided by 4 is 6 centimeters. So for every Charlie, It's 6 centimeters. I think we've solved it, but we have to check. I already said that I have to have a square, a perimeter of 24 centimeters, and what are their side lengths? And I'm saying Charlie's side lengths are 6 centimeters. Well, in order to check that out, we better start here. And we can write it down, but I think we can add in sixes. So if I go from here over here, that's 6 centimeters. And then I go from here up here, that's 6 more, so that's 12. And then I go over here, that's 6 more, so that's 18. And then back to where we started is 6 more, that's 24. Checks out. I'm happy that we solved this equation. And all we had to know that a perimeter, something that goes around the outside of something, and that a square has 4 equal sides. That's it. Okay, I'm going to cue up another one. Hold on. Okay, Grampy's back. Took the sweater off. It's a little warm in here. Okay, let's move on to something. It's not more difficult. You just have to think about it a bit differently. If you know that the perimeter is something that is the length of something that goes all the way outside and around something, whatever shape that is, then the area is the total amount that's inside. So let me say it like this. Let's have a rectangle that is, I don't know, let's make it easy, 3 centimeters, and each one of the height and the width is 4 centimeters. So, I told you it's a rectangle. That means that this side is the same side as this side. So let's write it down. And this side here is the same as this side. So let's write it down. Incidentally, I always write down as much information as I think that I need when I'm writing down equations and I'm working out problems. And as a math teacher and as a math student, I find that if you let your math teacher know that you are actually working through this problem and you make a silly error over here, you might get some credit for the amount of effort that you did over here. That's all I'm saying. I know I did. All right. What do we know about the perimeter? Well, the perimeter is, well, we just had this. It's the length around the whole outside. And in this case, I'm not going to insult your intelligence. It's 4 plus 4 is 8 plus 3 is 11 plus 3 8, 6, 14. Okay, so the perimeter around the outside is 14 centimeters. You start anywhere here, anywhere, and go around and come back to the same spot, and you'll go 14 centimeters. Okay, now the area is a different beast. Area is the length times width, and that's specifically for a rectangle. It also works for a square, but that would just mean that this L is the same as this L, and that's why we say length times width. But in a square, we'll see that the sides are just, these sides are all the same. So in this case, though, we picked a rectangle, and here's the rectangle. I want to know what the area of that rectangle is. Well, I told you the formula for it. It's just the length of it times the width of it. So the length of it is, well, let's say the height of it in this case, so the length and the width. It's one of the two, so pick one. Length is usually longer. 4 centimeters times 3 centimeters. And that gives you 12 centimeters squared. Squared because the centimeters, when you keep the units, will tell you that you're getting centimeters times centimeters, and that's a square unit, which means that you would have 12 of these squares inside your rectangle. So you could fit 12 squares, 12 square centimeters in here. So let's just see if we can do this as proper. What did I say? This is 3 centimeters long. So let's do it like this. 1, 2, 1, 2, 2, 1. And this was 4. 4. There. So I said, well, what's the area of it? And I said, well, you can find it out by multiplying the length times the width, or, which we did to get 12 centimeters, or you could draw all the tiny little cubes that are in between and add them all up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 675 million. No, joking, 12. 12 centimeters. So you have to know that And you have to know how to calculate the areas of certain things because they're not always that easy. Let me give you an example. A triangle, for an example. A triangle, you can't use the length times the width. Which one do you use? No, right? Triangles have things called heights that are different than the lengths of the sides. Sometimes the triangles can all have the same sides, be the same length. Sometimes you'll have all but two triangles where the angles are larger than 90 degrees. They're all triangles, a shape with three sides. But there's a same way that you use every time to calculate the area of a triangle. And it's 1/2 the base times the height. The area of a triangle is 1/2 the base times the height. And you go, which one's the base? Pick one. Pick one. Really, you can orient that any way you want. All I'm telling you is that height is only going to be one place. In this case, this would be the base, this length, and the height is really here. Well, you didn't give me the height. How do I figure that out? I go, well, you have to have some pieces of information to calculate other puzzles. So, I'm going to pause now. I'm going to put up another one that's going to calculate backwards. It's going to make you think a little bit about trying to find maybe the length of something from the area of something. Okay, hold on. Okay, I told you I'd be back, and here I am. Let's read the question together, shall we? Beautiful picture of a triangle. You look inside the triangle. What do we have? We have the height of the triangle. I drew a pretty standard triangle, base across the bottom. Now the height, what I failed to mention before, was that the height always makes a perfect perpendicular with where you're coming from, to the top of the triangle down. So you can't have the height over here, obviously. The height is exactly how tall it is. Same way exactly how tall I am. Straight up. Straight up. So, what's the question? What is the base length, presumably, if the area is 20 centimeters squared and the height, h, is 5 centimeters? OMG. Too many things going on. But wait a minute, it isn't. The area of a triangle is quite easy. It's 1/2 times the base times the height. That's it, in something sort of square units. We know that. We know that the area is right here in the formula, or in the question, 20 centimeters squared. There's one, and if h is 5 centimeters, well, geez, all we're missing is the b, which is what we're looking for. So we got a case of, let's use a formula and some numbers, and then sort it out. Here's where people mess it up. Not sure what to do when you start substituting letters in for numbers and numbers in for letters. So let's go through it, but nice and easy, all right? Again, the area is right here. Height is right here, and all we need is the base. So let's write the equation down. Area is 1/2 the base times the height. The area, we know, 20 centimeters squared, equals 1/2, that doesn't change. The base is what we're looking for, and the height is 5. Now, when numbers and letters are jumbled up like this together, so I don't get confused, you can either, we're beyond using multiplication signs now, you can either use a dot in here, or you can just keep them together. In this case, you have to know, though, that if these fractions multiply together, b over 1 and 5 over 1, all that together is just 5 still multiplied by b over 2. These fractions are multiplied together, 1/2 times b times 5 over 1. Multiply the numerators, multiply the denominators, 5b over 2. So now that we kind of get rid of this little mess in the middle here, all we did was substitute numbers for letters and letters for numbers. Numbers for letters. Now let's see what we have. Well, we have a 20 over here. And let's drop the units for now because I know that I'm going to go for a side length. And sometimes it just makes the equation really messy. Equals 5 times b, the base, over 2. This is where folks mess up. How do I I only want this thing. What's all this stuff that's multiplied and divided by it? They're rules. It's just rules. Let's look at right here. Let's make a little more room up top. 20 equals 5b over 2. I'm going to try to isolate that b from everything else. Keep it on one side of the equation and keep everything else on the other. So what I'm going to do right off the bat, it's being divided by 2 on this side. This whole thing is being divided by 2. If I want to get rid of that ugly old 2, if it's being divided by 2, what if I just multiply it by 2? If you divide it by 2 and multiply it by 2, you're just multiplying by 1. Well, there you go. Well, wait a minute. We did something to one side of the equation. We better do it to the other. So if you multiply one side of the equation by 2, you have to multiply the other side. That's how it's fair. You steal 2 apples from this guy, you got to give 2 apples to that guy. So what are we left with? Well, on this side, 2 times 20. That's easy. I can do that in my head. Equals 5b. Well, again, I'm just looking for the b, and right now I got this pesky old 5 being multiplied to it. So let's divide 5 out of this equation right here. Oh, whatever you do to one side, you have to do to the other. Divide by 5, and now we have a b, as this reduces to 1, is equal to 40 divided by 5. 40 divided by 5. 40 divided by 5. 8. 8 times 5 is 40. So now we have a b equals 8. 8 equals b, or b equals 8. You can change these back and forth. They're equal signs. You can swap them back and forth because one side on one side is equal to something that's on the other. So there's our answer. And by the way, teachers like when you write the answers in big boxes so they look at all over these scribbles and they're going, oh, okay, I don't have time. I got to rush home and feed the dog. And oh, it looks like you got it right. And click. Joking. Teachers like to go through your things. I know as a teacher and as an instructor sometimes with mathematics, I would look at this and go, okay, clearly we had a plan, we have a picture, knows what the height is, here's the base, area clearly is here. Now if I ask what the perimeter is, you could work it out, but you'd have to know a little Pythagorean theorem here because you have to an h and a b, and you have to know where it was separated. So a little bit more trig coming up. But for right now, I think we solved it. But do we know for sure? How would we know for sure? Oh, well, there's one way. Let's test it. So if I said before that we had a triangle and it had a base and a height that equaled 20 square centimeters, well, surely we better plug those numbers in and see what we get. Because if that base isn't 8, we get trouble. We get trouble. The area is equal to 1/2 the base times the height. The area we said was 20 square centimeters. And on the other side, we have 1/2 of 8 times the height, which was, what did we say the height was? I think 4, right? 4? No, 5. 5. That's the multiplication side. 5 centimeters. So now we have 20 centimeters equals to 8 times 5 is 40, divided by 2 is 20. And it works out. So 20 centimeters does equal 20 centimeters. And we figured out that for that question, if you're given an area of 20 square centimeters, a height of 5 centimeters, then we figured out that the base was 8. Just by working backwards and forwards through multiplication and division to figure out another problem. All right, pause for the next one. We're back, Charlie. And this time with one of my favorites, the circle. In my opinion, probably one of the most perfect structures. Perfect. Anywhere you stand at the center, you can rotate around it any place and fire out the exact same distance. There are some really cool things that go on within algebra, within calculus, within circles, within... I'm not going to get into it. I'm not going to get into it. Just suffice it to say that circles are really cool. Circles are cool for so many different reasons, but we're going to touch on one really shortly. because there's something about a circle that happens, a perfect circle. Every time, it doesn't matter how big it is, every time that you divide the circumference, the perimeter of a circle by its diameter, you will always get the same number. And it's nothing in math is true unless it's proven, and that's why math is the purest of the sciences. Just saying. Like I always point out, physics, give a lot to physicists, it explains the natural world, but and how it works. But math is its language, 100%. So circles, let's get into it. The area of a circle, well, let's go back. What's the area of a square? Well, it's any one length times itself, because it's a square. It has 4 sides, so its length times itself 4 times is the perimeter. Its length, added together 4 times is the perimeter, or multiplied together by 4 times. Its length times another side, or length, which is the same, is its area. A triangle, a half base times the height. We proved it. We looked at it. Did we prove it? I don't know. We can go in sometime and then add up all the little centimeters cubed and stuff, but same way. These are tried, tested, and true formula. The perimeter for this and any circle structure is 2 times pi times the radius. Now, let's explain the radius. The radius is the distance from the center out to any point on that circle. It's the same. That's why circles are so cool. There's a radius there. That's the same as this one here. That's the same as that one there. And the diameter, if you've paid attention, is just one radius times plus another radius. So the diameter of any circle, that's the span across it, its widest point, is just 2 times the radius, always. So if I give you the radius, you get the diameter, you multiply it by 2. The radius of a circle is 3 kilometers. What's its diameter? 6 kilometers. Can you have a 6-kilometer circle? Friggin' right! Earth is a big place. For right now, we know that the diameter is 2 times the radius. The area is pi r squared. So wow, we only need to know the radius and this crazy number pi, and we have the area. Wait a minute, we have the perimeter if we have the radius and this crazy number pi again. So all you ever really need with a circle to find out areas and perimeters is the radius. Sometimes they'll disguise it as the diameter. The diameter of this circle is 4 centimeters. What's the area? Damn it, they gave me the diameter. How do I solve that? Divide it by 2. You have the radius, 100%. So let's work through a problem. I'm gonna say, now we're gonna have to use our calculator for some of this because let's talk about pi. Okay? Right here, the perimeter or the circumference. When you're talking about circles, the area, the distance around the outside is their circumference. Circumference. That's the distance around the outside of the circle. So that circumference is equal to, as you've noticed, 2 times pi times r, which is 2 r here is just the diameter. So it's really pi times the diameter. Same thing. The circumference, this distance around the outside, I know, check it out. You can find that distance around the outside with that and this crazy number pi. So how do you get pi? How does it? Now I'll tell you what we did in school, and I thought it was a really fun exercise. Take a compass and do the best circle that you possibly can. Make it as big as you can on a piece of paper. Then you take a piece of string and you start at one point here, and you gently lay the string down along the circle, as close as you can till you get to here. And then you measure what that distance is. Okay, are you with me so far? So now you have this distance, this circumference. You've already measured it with that string. It'll be some number, right? And then you can measure the distance across as the diameter with a ruler. It's a straight line across the biggest point. And that number is pi. And that number is pi, which in decimal form is 3.141592, I think 653 or something like that. Do you know there are people that have this is an irrational number, it goes on forever, it never repeats. That's a lot, less than a lot later on, but right now know that this number is very close to 3.14. And when you see 3.14, which is why sometimes in March, on the 14th, they'll call it Pi Day. Now you know. Why is Pi Day, pi, Greek letter, on March 14th? Third month, 14th day, 3.14. Pi Day. Make sure you get pi on Pi Day. All right. Now, what does that mean? That means that number pi is the same for every circle, whether it's this big or whether it's this big. You're always dividing the ratio. Well, you can't be the same number for that little guy. Yeah, because it's the ratio of this all around the outside to that diameter that's going across the middle. So this one, this one, this one, and this one, if they were perfect, and those are perfect diameters, and you measured around the outside and you divided by the diameter, you would get pi, 3.141592. It's really pretty cool. So based on that, now that we know pi, and it pretty much stays the way it is all the time, forever and ever and ever, what can we do for areas? What can we do for problems? The same thing that we did before. The absolute same thing that we did before. You apply the problem, you look through the problem for what you're trying to solve, and then you look at the formulas that you know, because we've shown how they work and how they get these numbers, and then you apply them. You write down start with a diagram, and I'm going to give you right off the top of my head. There is a circle of radius 4 centimeters. What is the area? Wow, a circle of radius 4 centimeters. That's not very much information. But I do know a lot about circles now. There's the radius in there. That's any point from there to the outside. And I said that was 4 centimeters. 4 centimeters there, 4 centimeters, 4 centimeters. Well, here's the area formula here. And pi, that's that same number over and over and over again. And the radius is right there. Ooh, what's that square mean? Means that it's multiplied by itself. That would be the same as writing pi times r times r. Same thing, r squared, an exponent. In our case, we have area is pi times 4 centimeters squared. Well, those are just numbers. Just numbers. I bet you on your calculator you can hit the pi button, and I bet you it comes right out to 3.141592, however long your calculator is. And 3.14 times 4, let's write it out again. Pi times 4 centimeters times 4 centimeters, because that's what squares mean. This times itself again. So that's 16 times pi square centimeters. Now, you could ballpark it, you know what? Let's do it just for fun. Because we could use 3 and that would be too easy. But you know what? 3.14, let's multiply it. Let's go 3.14 times 16 to get a really good number. 6 times 4 is 24. 6 times 1 is 6. Plus 2 is 8. 6 times 3 is 18. 1 times 4 is 4. 1 times 1 is 1. 1 times 1 is 3. Add them up. 4, 12, 8, 9, 10, 3, 4, 5. And then 2 decimals over. 50.24. So if you multiply 16 by 3.14, then you will get roughly 50.24 square centimeters. And that's the area. Yeah. There's not much more than that. Recognizing that r squared is r times r. It's the same thing as saying length times width, except it's not, because, well, it'd be the same thing as saying length times width if it was a square, because it would be length times length or width times width or whatever that side was. Same here, it's just r times r. And this magical pi number, which now you know what it is. It's any circle. The distance around the outside of that circle, or its circumference, divided by the length across it, its diameter, is 3.1415 every time. Doesn't matter how big that circle or how small that circle is. And that pi will help you solve a lot of problems. So some teachers like it, 16 pi centimeters squared, and that way you don't have to go chucking it into a calculator and get some god-awful number. But that's all there is about this part and for circles. We can always work backwards. I could give you 50.24 centimeters squared and tell me what the radius is. Well, you should work back to something very close to 4. And that's the way that you can go and test this theory on. You know that you're good with your calculator too, because some of these ones, when you start squaring decimals and when you start including decimals, it makes it very, very hard to make problems up that, you know, work out really nice and naturally and evenly. So what have we done today? So that was a previous, you just go back and watch the video. I think that's all I have tonight for you. If you want anything else by it, just know that math is what makes the world go round. You know what? Let me just leave you with a final. If you haven't done it yet, I did a math degree in my mid-40s. Now I'm not blowing smoke up my own arse, but I'll tell you, it took some doing. Notwithstanding that I was being a dad, doing a bunch of stuff like that at the time, but it was a true test. And I will tell you that I went through school and I hung on to probably the smartest individuals that I could find. And incidentally, I was right, because they went on to become PhDs and masters, and they had a couple are straight up doctors now, and one's my financial advisor. Not joking, he's a great guy. Anyway, probably forgotten more about math than I'll ever know. All I'm telling you is the ones that succeeded, the ones that were good, and I can tell you there were a lot that came from high school full and ready to go. They just weren't academically ready. And I'll tell you where it started right now, and I'm seeing it across the board. Learn your multiplication tables. Learn what numbers multiplied by each other are. Like, know what they are. Wouldn't it be great to know that if you were going to give, if you had $50 in your pocket and you wanted to give, you had seven folks kicking around that you had to pay a certain amount of money to. Wouldn't it be nice to know that you could pay 7 of them $7 a piece and have $1 left over, because 7 sevens are 49. You won't believe how this comes into play through the rest of your life. Everyone's on your phone now, and I get it. Calculators are thrown in your face. Multiplication has lost it in some cases, the idea behind multiplication for some folks, because you don't realize that it's not anything magical. It's just 7 groups of 6 or 6 groups of 7. Multiplication is just addition, right? 3 times 4. That should be 12. Just bang, off the top of your head. No problem. And I'll tell you why, because you're going to get into division later. And you should know that 3 goes into 13 4 times. You can't go any more, because you know 3 times 4 is 12. My biggest bit of advice for new parents, despite what's being taught in school, and you know, in conjunction with what's being taught in schools, I'll never fault a teacher for their methodology. All I know is old school, and old school worked for me in my mid-40s and got through a maths degree because I knew the basics, and the basics start at the very beginning, obviously, with multiplication tables and straight up fractions, addition, subtraction, multiplication. That's it. If I were to do it all over again, I would have my old school chart on the fridge from the 1 to the 9s across the top and across the bottom, and I would have all my little monsters know that 2, 3, 4, 2 times 4, 2, 6, right? Do this out so that the 7/8 are 56, 9/6 are 54. You're struggling with it yourself, practice. There's one that, and it's funny because I had a student quite regularly come for tutoring last year, and they all struggle with the multiplication tables. And I will tell you that it's repetition. Sidney Crosby hits the top shelf because he's done it 600,000 times. Repetition, walk by, test yourself on them. Because once you know these, then you know how many times things in division work so much easier. These are the building blocks. Addition and subtraction, multiplication, division are the building blocks. Just think of it like the alphabet of the mathematical world. And all the other sciences, all of them use this. Business folks use math. It is, and it hasn't changed a whole lot in hundreds and hundreds of years. Gotten very good at. Think of the math involved in putting well, watch the movies, in putting an astronaut in space. It's insane. Okay, that's all for me tonight. I hope you had a good time, Charlie, and I hope it was worth it. See ya.